The diagram below shows part of an electric circuit. Oh, for the last time ever. That's it. What's the current and its direction through the 5 ohm resistor? Okay. Well, I said to myself, I definitely have those flowing out. So I said flowing out, I have 0.75 plus 0.53. 1.28 amps going out. Coming in here, I only have 0.96. That doesn't work. The current must be flowing in. So if you wanted a direction, you could say, if you said to the right, or if you said inwards or towards the dot, or something like that, the direction is flowing. Or if you said, however you phrase the direction. And the magnitude, it's going to be 1.28 minus 0.96. I should have done that in my head. 0.32, is that correct, folks? Yeah. So 0.32 amps, 1 mark. And direction, I'll say to the right or down and right, or if somehow you indicated with an arrow that it's going that way. That gets you 1 mark. Yep. Yep. Okay. Number 2. Total resistance. Okay. I'm going to combine these two because they are in parallel. So the first thing that I'm going to do is go 1 over R parallel, which is going to be 1 over 10 plus 1 over 10. And then I'll take the reciprocal. 1 over 10 plus 1 over 10 is 2 over 10. If I flip that, it's 10 over 2. I'm pretty sure that this ends up being 5 ohms, that these two can be replaced with a single 5 ohm resistor. So now I'm visualizing this circuit as battery, 20 ohm, 5 ohm, 20 ohm. Those are in series. I think our total is going to be 20 plus 20 plus 5. Is it 45 ohms, folks? Is that right? That gets you 3 out of 3. Otherwise, I would give you 1 mark if I saw that, 1 mark for R parallel, and then 1 mark if you added the series. And now I'm good to go because I have I total is going to be V total over R total, the total voltage. By the way, this is a terminal voltage because they didn't bother separating the internal resistance, so that's not the EMF, it's the terminal voltage, but that's fine. It's going to be 15 divided by 45. Is it 0.333333 amps? No? Yes? Oh. So 2 out of 2 if you got that. Otherwise, I would probably give you 1 mark if I saw that, half mark for that, half mark for the answer. If you got A wrong, but you went 15 divided by your answer from A, I would give you 2 out of 2 for part B. What's the voltage drop V1 across R1? Oh, that's not too bad because it's going to be 0.333 amps. So it's going to be I times R. It's going to be 15 divided by 45. I'll get that on my calculator times 20. Is it 6.6 repeating? 6.67? Yeah. V equals I times R, which is going to be 0.33 times 20, which is 6.67 volts. I would probably give you 1 mark if I saw Ohm's law and 1 mark for the answer. Something like that. But again, 2 out of 2 if you got it right. What's the terminal voltage? The terminal voltage is going to be 15 minus whatever I lose going through there. Well, I should label downhill. I think I forgot to do that in the last current. I don't see amps anywhere because if I know total current, the question's going to fall apart. I don't see 2 things anywhere. I'm going to have to rewrite this. So the first thing I'm going to do is I'm going to combine 1 over R parallel, which is going to be 1 over 10 plus 1 over 10. I'm having a bit of a deja vu moment. I'm having a bit of a deja vu moment. I'm having a bit of a deja vu moment. Nothing? Okay. Anyways, I think R parallel ends up being 5 ohms. And so I think our total is at 5.7 ohms, yes? Or am I totally wrong? Yes? And so I total is going to be V total over R total. It's going to be the total theoretical voltage divided by 5.7. This is going to be a yucky decimal, but such is life. And I get 2.631578. I'll go 2.63. I'm going to write 2.63, but I'm going to store this on my calculator. 2.63 amps. And now I can say the terminal voltage is going to be the EMF minus I times what I lose going through the battery, I times little r. It's going to be 15 minus 0.7 times 2.63. But Nick, you know I'm using my answer button there. It's going to be 15 minus 0.7 times answer button. I know it's going to be less than 15. If this was multiple choice, I would cross out any answers that were bigger than 15 or equal to 15. Do you get 13.157, 13.2? I would take probably 13.1 because depending on if you use this or use your answer button, 13.2 volts. If you got that 4 out of 4, otherwise I would give you 1 mark if I saw R parallel, 1 mark for finding that, 1 mark for finding the total current, and then 1 mark for finding the terminal voltage. Suppose the 10 ohm resistor is removed. The terminal voltage will. Now you could simply crunch this and find out what the new terminal voltage is, because the new R total would be 10.7 because we pulled one of these. And now these two would just be in series, Nick. So 10.7, and I could go 15 divided by 10.7. There's my new I total. And I could then go 15 minus I times R, and I can actually get an answer. It has gone up, it seems. But let's see if I can do it intuitively. So it is going to increase. Why? If you crunched it, that's fine. Removing 10 ohm makes R total increase. When you remove a resistor in parallel, it increases total resistance. Therefore, I total decreased. Therefore, I times R decreased. And since terminal voltage equals EMF minus I times R, it's bigger. And if you crunch it, R total increased to, what was it? 10.7, not amps, Mr. Dueck, ohms. I total decreased to 1.4 amps, and V term increased to 14 volts. Is that okay? Now, if you said something along these lines, I would give you 2 out of 2. I notice I wrote down 1, 2, 3, 4 statements. If you wanted me to be really fussy, I might say a half mark if I saw that, a half mark for saying that, and then I'd probably give you 1 mark for somehow combining that and that in one sentence and saying they got bigger. But if you just crunched it, I'll give you full marks. Number 4, the 4 is here, but we're on the next page. What's the power dissipated in the 16 ohm resistor? I'm going to have to rewrite this because I don't see current anywhere. One over R parallel equals 1 over 16 plus 1 over 25. R parallel is going to be 16 reciprocal plus 25 reciprocal. I don't think this is going to work out nice. 9.7561 ohms. So R total is going to be 7 plus 9.7561 plus 1 ohm. It's going to be 7 plus answer button plus 1. Do you all get R total is 17.756? And since there's a 0 after the 6, that seems like a good place to just stop writing stuff. R total, now I want to find I total. That's going to be V total over R total. It's going to be what was 15 is the EMF divided by 17.756. I'm going to use my answer button. 15 divided by answer button. This is going to be yucky. 0.84478. Okay, this question's going to fall apart. What do they want me to find? They want me to find the power in the 16 ohm resistor. Well, first of all, I know that 0.84478 amps goes through there. Is that the current you all got as well? People nodding? So if I want the voltage up there, it's going to be I times R. 5.91346. Yeah, 5.913. And that's going to leave, oh, and through here I also have 0.84478, which means I lose 0.84478 volts going through there. So now if I go starting with 15 volts minus the 5.913 minus the 0.84478, in that 16 ohm resistor, am I losing 8.24175, 8.24 volts? I could figure out the current, but now I'm going to go power equals V squared over R, since I happen to have the voltage there. And so it's going to be this number squared divided by, what was it, 16? Y'all get 4.25, 4.24, 4.2 watts? I'm not seeing any nods. Yes, some nods? Yeah. So I'll go to 2 sig figs, 4.2 watts of power. If you got that, I would give you 7 out of 7. Otherwise, how would I give out part marks here? I would definitely give you 1 mark if I saw that. I would give you 1 mark for R total. I would give you 1 mark for I total. I would give you 1 mark if you found the voltage in little r. I would give you 1 mark if you found the voltage in the 7 ohm resistor. That's 1, 2, 3, 4, 5 marks. I would probably give you 1 mark if I saw that, and 1 mark for the answer. There are other ways to get there. You absolutely could have found I and gone V times I, or you could have found I in here and subtracted to get there. There are many other ways that we could have got there. I chose the shortest way. If you're wondering at first, again, if you got the right answer, then Jacob, 7 out of 7. Otherwise, if you're wondering about part marks, you can lawyer with me. Now is the time. Otherwise, if you could give yourself a lovely score out of 23 at the top of this quiz, please.